Good morning, ladies and gentlemen. Welcome to Kaduna State Senior Secondary School Online Connect, which is powered by exponential computers. Previous lesson for SS3 students. I, the presenter, Ismail Baraya. So, for physics lesson or for physics class, here are the contents that we are going to talk about. The first one is the concept of field. We have gravitational field, we have electric field, and also magnetic field. We will also talk about the differences between gravitational, electrical, and magnetic fields. We will also talk about the properties of force field, followed by the magnetic field using compass needles. Concept of field. So, a field is a concept introduced to describe a region under the influence of some physical agencies such as gravitation, electricity, magnetism, heat, etc., and so on and so forth. So, when we say field, it is a concept introduced, it was introduced or it was created to describe a region under the influence of some physical agency or physical quantity. When we are talking about physical agency, we are talking about the physical quantities, and those quantities are the gravitation, electricity, magnetism, heat, etc. So it was created to describe this region, and those regions, they are the gravitation, the electricity, and so on. So it is a physical agency. It was introduced to describe a physical agency under influence of some physical quantities or physical agency. That is field. That is the definition of field. A field, it was introduced to describe a region under the influence of some physical agency or physical quantity. Okay, there are some kinds of fields that we are going to talk about: the gravitational field, the electric field, and magnetic field. These ones are the ones that we are going to talk about for this lesson or this class. Gravitational field. Okay, whenever we are talking about gravitational field, what will come to your mind is the gravity. Normally, a gravitational field, it comes from the gravity. Okay, so when we say gravitational field, is a force field that exists in the space around every mass or group of masses. Okay, that means that not only one mass, a group of masses. That means that there are many of the mass. Okay, a gravitational field is a force field. Okay, when we say force field, it is a field that don't have to be in contact with the body or with the particle. Force field, it comes from the types of field. Normally, we have two types of field. We have a contact field. We have a contact force and field force. That is the two types of forces: the contact force and the field force. Okay, and the force field. Okay, this force field, it is a force that don't have to be in contact. It will not be in contact with the particle or with the object. Let me give you an example. If you see something, you see a ball. If you throw that ball, you use your energy, you use your force and throw it away. So you touch that ball. That is why it moves. If you have not touched it, it will not move. Okay. So this force field, it is a force that will not be in contact with the object. That force will not be in contact with you in order for you to move or to do something like that. Okay. Also in space. Whenever we are talking about space, we are talking about the sky, not on the ground, around every mass or group of masses. It's said to exist near anybody that possesses mass. Okay, that means that each and every body that have mass, the gravitational field or the gravitational force already exists there. Okay, when we say mass, we are talking about the quantity of a body or of a particle, that is mass. So each mass that have each mass that have a each quantity that have a mass or each body that have a mass, the gravitational field already exists there. So it is a force field that exists in the space around every mass or group of masses. Okay, so let me give you an example. When you take a ball, when you have a ball in your hand and you use your force and throw it off in the sky, so if you throw upward, straightly upward, if you throw that ball in the sky, that ball will go off, will go off until it reaches some certain level. Then it will start coming down. It will start coming down gradually. Then that velocity that it's coming, it will start increasing. She will come down with the heavy force. So that force or that energy or that field that is absorbing that ball to come down, that is calling or catching that ball to come down, is the gravitational force. So you see that force, you cannot see it by your own eyes. You will not see it because it is not in contact. It is not in contact with the particle or the object. It will force that object to come down. So you see, it is due to the gravitational force. It is due to the gravitational field that ball has come down to the ground. So it is the work of the gravitational field. Okay, so this is the formula for the calculation of the gravitational field, that says Pg small g is equal to capital G. Okay, this capital G normally is the universal gravitational constant. So this G, capital G, has a constant value of 6.674 times 10 to the power of minus 11 meter cube per kilogram per meter square. So this value normally is constant, and when we say constant, we are talking about something that is not changing. So this is the universal gravitational constant. Okay, this formula that we are seeing here, the m1 and the m2 all over r square. Okay, this m1 and the m2 are the masses of the objects. So when we say mass, also we are talking about the quantity. Okay, so and the r normally is the distance between the center of the object. R is the distance between the centers of the object, between the m1 and the m2, the distance between them. So this formula normally it's not just created like that. No, it is a law. It is called a universal law of gravitation, which is it was discovered by one of the best scientists, Sir Isaac Newton. He is the one that discovered this formula or this law. So today we are talking about only the definition of the gravitational field, which says is the force field that exists in the space around every mass or group of masses. So maybe one time allowed us, we'll talk about, there is a lesson or a class that will have a calculation of the gravitational force, how we calculate the gravitational force. Okay, the second one of the field that we are going to talk about is the electric field. Okay, so when we say electric field, what will come to your mind is the electricity. Normally you already know the electricity. The electric field, that force from that field, it already comes from the electricity. It is not created by like that. It comes from the electricity, and the electric field or electric force, and it is a field or whereby that particle will experience a force will know that a force enter through it, whereby due to the use of the charged particle, and those particles are the positive charge and the negative charge. Okay, these two charges, they are the one that created the electric force or the electric field. Okay, electric field can be defined as the region of space around an electrically charged particle or an object in which the charged body experience force. Okay, this particle, it will not just experience force, but due to the electrically, and when we are talking about the electrically charged particle, we are talking about the terminal, the positive terminal and the negative terminal. So this definition is originated from the electricity, from the charged particle, electrically, from the electricity, and from the electricity we are talking about the particles, and those particles are the positive charge particle and the negative charge particle. Okay, so if you are seeing this picture or this diagram here, this the positive one, it is the one in the red, and the negative one is the one in the blue. And this line that you are seeing, they are the electric force field line. They are the force field line of the positive terminal and the negative terminal, or the positive charge and the negative charge. That is these two charges, they are the ones that created the electric force or the electric field, whereby that object will experience a force has entered through it, and that field or that force, it is created from, maybe from the maybe you use a power. So that power, it is the source of that electric field. It is from that power that we have that kind of force. So it is due to that power. And when we are talking about power, we are talking about the energy. So that is the electric field, how it was originated. Electric field, an object in which the charged body will experience that force, then that body, it will experience how a force has entered through it. It will experience that there is a force in that object, and those forces are these two terminals, the positive charge terminal or the positive charge particle and the negative charge particle. So this formula that you are seeing normally is the formula of the electric field. And the electric field, the SI unit of the electric field, it's in Newton column or Newton per column, or in voltage. When we say volt, we are talking about the voltage, and I told you when we are talking about the voltage, we are talking about the power, and when we are talking about power, we are talking about the energy. That is volt per m. That is the O, the Newton, the N for C, that is the Newton per column. So the formula for the electric field is the force in Newton, that is the SI unit of the force in Newton, all over the charge Q, that is the in column. So this formula is used to calculate electric field or electric force. Okay, this is the third field among the field that we have been talking about, the gravitational field. It comes from the gravity, due to the gravity, that where it comes from. Okay, the electric field, that is from the electricity, from the charged particle, that is where how they are. Okay, so this is the magnetic field. Okay, the magnetic field, what will come to your mind is from the magnet. That is how the magnetic field or how the magnetic force come to arrive. Okay, magnetic field is the region around a magnetic dipole. or moving charge generate a field. This field is known as magnetic field. Okay, this says a magnetic dipole. Okay, when we're talking about the dipole, we're talking about the like just like the normal cardinal point, the north, south, and the east and the west. Those 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 cardinal point. Okay, for the magnet, normally a magnet it only have a north pole and the south pole. That is how it was named. So, and they are being called a magnetic dipole. So this north pole, it is like the front or the head of the magnet, and the back one is the south, which is the south pole. Okay, let's take an example of two magnet. Let's take an example of we are having a two magnet. Okay, a two magnet that are facing each other, the north pole and the north pole also. The north pole of the first magnet and the north pole of the second magnet, they will never be in contact. Why? Because they are in the same gender. Because they are in the same gender, then they will not attract. That force will not exist between them. They will not generate that field. They will not generate that force. So, but maybe if we turn one magnet to face the north and the south will face the north, so then we will be having just like this diagram or this picture, just like the one above, the north and the south and the north and the south. Okay, the south and the north, if you look at it normally, the blue one is the south facing the red one, which is the north. So if you see it, the opposite poles, they will attract. The north pole and the south pole, they will attract, they will generate that field, they will attract each other. Why? Because they are not in the same gender. Just like the electric field, the red one and the blue one, they will never be in contact with each other. Okay, that is for the north and the south. Okay, the south and the south, the end of the magnet, that is the south of the first magnet, and the end of the second magnet also, that is the south of the second magnet, they will never be in contact with each other. They will repel, they will refuse each other, because they are in the same gender. So there is no generation of field, there is no generation of force between them. But when they are in opposite force, when you interchange them, just like a gender of a male and a female, a male will attract a female, but a female will not attract a female, because there will be no production. There will no production, because they are in the same gender. But if you interchange them, then you will see there is a attraction between them, just like the magnet. So normally when we are having a different portion of the fault, the north pole and the south pole, there will be an attraction, there will be a generating of a force there, of a force field. Okay, and if you take the north pole of the first magnet and try to attract it with the north of the second magnet, you will see that the second magnet will withdraw back. It will not be in contact with the first magnet. So, and when you take the south of the first magnet and join it with the head or the face, that is the nose of the second magnet, you will see that they will be in contact with each other in a short period of time. So normally the metals, they are the one that are attracted with magnet. You will see they will attract each other. That is the conductors. Normally the conductors, they will attract each other. But the insulators, and when we are talking about the insulators, we are talking about those that don't have charge. They don't have charge, so they will not attract, just like something like a pencil. You see, a pencil will not attract a magnet. So just like those ones, the insulators, they are not conductors, they will not attract magnet. So maybe when you come with a nail or a spoon, they will see, or a metal, you see they will attract that magnet. So normally magnetic field, it comes from the magnet. That is for the electric field, the magnetic field, and the gravitational field. Okay, then here we will be talking about the differences between the gravitational field, the electric field, and the magnetic field. So if you see, they are in tabular form. So the differences between them, the gravitational field. So one of the differences between them, between the gravitational field and those two, the gravitational field act on all masses, or act on all mass and energy. That is for the gravitation. It acts on all mass and energy. Also, the second difference of gravitational field is that gravitational force are only attractive. You see, the gravitational force are only attractive. They will only attract. The gravitational force don't know about the repulsion. The gravitational force, it only attract. Okay, then the electrical field, or the electric field. Electric field act only on charge particle. So you see, the electric field, it will only act based on charge particle, based on the terminals, the positive charge particle and the negative charge particle. That is where the electric field will only act on it, the charge particle. The second differences of electrical field or electric field is that electric field can be attractive, and they can be repulsive. You see, it differs from the gravitational field. The gravitational field don't know about the repulsion. Okay, then the differences of magnetic field to those two are the magnetic field act only on moving charge particle. You see, the magnet, I told you, they will push each other if they are in the same fold, or they will attract each other if they are in different fold. When you are having a different fold, you see they will attract each other. You see, the charges, it is moving, it is a charge particle. The particle are moving charge particle. Okay, the second differences between them is that magnetic force occur between two objects in motion. You see, also they are in motion. The ones that are in motion, then they will occur on it, between those two objects. That is what the differences between the gravitational, electrical, and magnetic field. All of them, they have their differences. You will not see those ones that have the same, that are in the same. Because if you look at this one only know about repulsing. This one, they can be attractive and repulsing. This one, it is act only on moving charge. You see, that is the difference. So that is for the differences of gravitational, electrical, and magnetic fields. Okay, here are the four properties of force field. Okay, the four properties of force field. In simple terms, a force field in physics is the area that is affected by another force. I told you the force field, it is a field. It will attract another force by another force, just like the one that I told you. The force field, it is not in contact. It will not. It don't have to be in contact with the object or with the particle. Unlike the contact force, that is the one we are not talking about, the contact force. So the force field has to be in contact. It is the area that is affected by another field. Okay, the number one property of force field is any force acting on a body falling toward the center of the earth is given by force is equal to mass times the gravitation. You see, this one is talking about the gravitational force. Any force acting on a body falling, you see, towards the center of the earth. You see, I told you if you throw something in the sky, it will fall down due to the gravitational force or due to the gravitational field. Okay, if you look at the second properties of force field, a magnet has the ability to attract magnetic material. Example, the steel or the iron. You see, this one they can attract the magnet, and if they are attracting the magnet, they can be the conductors, and if they cannot be, then they can be only be the insulators. They cannot attract a magnet. So example like a steel and iron. Okay, the third properties of force field is the electric line of force never cross each other. Okay, normally, even if you don't know this, when you have a red charge particle, that is a positive terminal and the negative terminal of a wire. So if you try and put them together, you will see that they will never be together. They will never cross each other, because due to the force of their repulsion, they will repulse each other. They will not attract each other. So the electric line of force never cross each other. They will never cross each other. Okay, magnetic field using this one is like a experiment or like an example of a magnetic field using a compass needles. A compass consists of a small metal needles which is magnetized itself and which is free to turn in any direction. Therefore, when the presence of a magnetic field, the needle is able to line up in the same direction as the field. Okay, so when you have a compass needles, and when you have a magnet, normally a compass, the one that we know or the one that you are seeing in the movie or in anywhere, the one that used to show direction, normally a compass it is used to show direction. So normally also a compass, it have a cardinal point. Yes, if you look at it, that there is the cardinal point I'm talking about. If you see, we have the north fall or the north direction, and also we have a south direction. We also have a west direction, and we also have a east direction. So if you look at it, this is the needles in the middle, the one that have a line, and on at the first of it there is a red mark. So that mark is indicating the force. It's indicating the force, the one that will show you if this magnet they can be attractive or they can be repulsive. Okay, if you have your own magnet just like this one, if this magnet we turn it, we assume that it is in the north direction. So you see, these needles of the compass, it will not be in this direction as the direction of 40, like maybe like it is at this direction of the 40 if it is in the north pole. Why? Because they are trying to be in the same direction, so they are not in, they are in the same gender. There is no attractive, they will reverse, the needles will change direction, maybe we go to 360 or 300 or 280. It will go to maybe to the west side because they will repel each other. But this one we are talking about, the one showing the compass, the needles trying to be in contact. So the north, the south pole, it is trying to attract the compass. If you look at it, it's trying to attract each other. That is the experiment of the magnetic field. The magnetic field trying to show you it is in attractive, they are not in repulsive. That is for the experiment of magnetic field using a compass needles. So this is the end of today's lesson. For the contents that we have already outlined it, and by the grace of God, inshallah, we already have to explain it. And I assume, I hope you you understand some of what I have talked about, or you understand most of what we have talked about. So I hope you understand, or you go and follow each and every one of them for you to understand, for you to learn more of physics, the concept of the field that we have talked about for the lesson of today, for the concept of today. So thank you for listening.